Hello and a warm welcome back to my YouTube channel. Trust you're all well and in good spirits. The purpose of this video is to review, not to introduce, the topic of moles, stoichiometry, balancing equations, and everything you need to be successful at 0654 IGCSE Coordinated Science. So let's begin. This is a tutorial by yours truly, Mr. M for Chem. Don't forget, smash that subscribe button. Thank you. So we start with the syllabus dot points. Stoichiometry, you have to use symbols, deduce formulae, deduce the formula, construct and use word equations, interpret and balance simple equations. If you get all of those things, you can have a C. That will get you a C because that's the core. Okay. Supplemental for those looking at A star to C. So these are the higher grades up here. You can determine the formula from the charges on the ions present and perhaps look at the periodic table and deduce what the formula should be given its position in the periodic table from its group number. You can construct and use symbol equations and ionic equations. They are very simple ionic equations. We'll have a look at that. Define atomic mass and molecular mass with reference to the isotope carbon-12 and make this up for ionic compounds. For the mole, there is no core for mole. It's all supplemental, it's all extra. So if you get in the mole, this should perhaps suggest to you that you perhaps want to do some more chemistry after 16. Maybe do the IB or the A-level or the AP or the HSC, whatever floats your boat. Okay. Define the mole in terms of Avogadro's constant, Avogadro's number. We'll do that during this presentation. Molar volume of a gas at room temperature and pressure, often called RTP. Okay, RTP is 24 decimeters cubed. You can use that in calculations. And then number 3, stoichiometric reacting masses, volumes of gases and solutions. And it may involve the idea of limiting reactants, which is where many students say, that's it, I'm done with chemistry, I'm leaving, I'm gone. Don't be one of those students. Hang around, because it does get very interesting. Let's start with first principles. So we're going to use symbols of elements and write formulae. Okay, so you should all know that the periodic table is arranged in order of increasing atomic number, and it's he, li, be, pkanofni, namg, al, sipsklar, potassium, calcium. Read it, he, Libebekanofni, namgal sipsklar, potassium, calcium. Okay. Use symbols of elements. Well, you only need to know less than equal to 20 for IGCSE. Yes, there could be some copper, bit of iron from the transition metals here, maybe a bit of zinc, but beyond those, you're not going to get technetium or maybe vanadium in a contact process. It's going to be in the first 20. So if you know group 1 is +1, group 2 is +2, these don't react. They're too noble. They're noble gases. They just don't react. Fluorine is group 7 or 17, so they're -1, and oxygen and sulfur are -2 in group 6 or 16, depending on the system that you are using. So you can write formulae, which we're going to have a look at in the next slide. Number of atoms, could give you the number of atoms and ask you to work them out. Now, what do you need to know for GCSE? You need to know that nitrate is NO3 with a charge of 1-. You need to know that sulfate is SO4 with a charge of 2-. You need to know that carbonate is CO3 with a charge of 2-. Those are the compound ions that you need to know. A compound ion, just more than one atom element, chemically bonded together, forming a group which will bond with a metal. Okay, so we start off fairly easy, and we're looking at 1 atom of sodium and 1 atom of fluorine. So sodium is group 1, fluorine is group 7. So that means that the group 1 is going to lose 1 electron, that's going to gain 1 electron. -1 + 1 is 0. So the formula is NaF. Calcium is group 2, so it's got a +2 charge. Oxygen is group 6, so it has a -2 charge. +2 minus 2 is 0. So it is straightforward. And it is CaO, calcium oxide. Magnesium chloride. Magnesium is +2. Chlorine is -1, but there are 2 of them. +2 minus 2 is 0. So it's MgCl2. All very straightforward, right? Yes, Mr. Midgley, all very straightforward. And then you look at this one. You go calcium's +2, but why are there 2 nitrogens and 6 oxygens? Why? Well, it's not going to be some weird N to N to O to O to O to O to O to O. That's just not going to happen. Okay, you've never seen that before, so don't get creative in the exam by generating things you've never seen before. You've never seen them, potentially, because they don't exist, which I would advise. So if you see something like this, it must be one of the compound ions, which I alluded to at the top. Clearly, it's a nitrate ion. Calcium is 2+, +2 here. Nitrate is -1 here. So yes, you've guessed it, it's one of those pesky brackets. Ca open bracket NO3 close bracket 2. That counts for my 2 nitrogen and 6 oxygen when we expand the bracket. Potassium is +1, oxygen is -2. So 2 times +1 is +2, -2 is 0. K2O, potassium oxide. Aluminium is +3, oxygen is -2. 3 times +2 is +6, 3 times -2 is -6. +6 minus 6 is 0, so it's Al2O3. And finally, sodium is +1, and then 2 sulfur and 4 oxygen. Okay, well that's this one, isn't it? SO4, 2 minus. That's Na2SO4, 2 minus. Sodium is +1 times 2, so that's +2. And sulfate is -2, 2 minus, so there's one of those. +2 minus 2 is 0, so that is a happy compound. Okay, so hopefully you can all deduce formula from number of atoms. It only becomes slightly complicated when we have a compound atom, anion. Construct and use word equations. These can be straightforward. They should be. Reactants are always on the left, and products are always on the right of this arrow here. It's a full arrow with a full head on the arrow. Sodium plus oxygen, you all know this, will make sodium oxide. Hydrogen plus oxygen, you could be clever and say dihydrogen monoxide, but clearly the answer is water. Lithium plus chlorine will give you lithium chloride. Potassium plus sulfur will give you potassium sulfide. And iron plus bromine will give you iron bromide. Okay, how do I know it says "ide" at the end? Ide, chloride, sulfide, bromide, oxide. Because if it's the element on its own, it ends in "ide." If it has the elements bonded with oxygen, it ends with "ate." Okay, so it's sodium plus oxygen, sodium oxide, iron plus bromine, iron bromide. Because it's just iron and bromine in the compound, no oxygen, bromide. Sodium and oxygen with no extra oxygen, sodium oxide. So, reactants to products, construct and use word equations. Easy, right? Now, balance symbol equations. We're using the same molecules so that hopefully it aids in understanding. So we've got sodium plus oxygen, Na plus O2. You need to know that all of the diatomic molecules, so you need to know O2, N2, F2, Cl2, Br2, I2, and there was one more, H2. So you should know all of these diatomic molecules which are at the top. I'm not sure the green pen is useful, so we'll just go over those. Inbred. There we go. So oxygen is Na. Oxygen is O2 reacting with sodium, and we're using the blue pen, so let's continue to do that. Now we're going to make sodium oxide, which must have some sodium and some oxygen in it. Now sodium is obviously in group 1. It's in group 1 and it's on the left hand side of the periodic table. Her hair, Libebikonovny, Nam, there it is, there's sodium. So it's got a +1 charge. Oxygen, her hair, Libebikonovny, is -2 over here, -2. So that does not equal 0. +1 - 2 is -1. So how do we solve that problem? Na2O, sodium oxide. Now there are 2 sodiums here, 1 oxygen, 2 oxygens, 1 sodium. So I need to do 2 of these, because now I've got 2 oxygens, and now I've got 4 sodiums. So 4 sodiums. So that balances 4 Na, 1 O2 goes to 2 Na2O. Happy days. Next one we can do is hydrogen with oxygen. Hydrogen is one of our diatomic gases. So we'll start with H2 plus O2 will make H2O. Clearly 1 oxygen here, 2 there. So we need 2 waters. Now we need 2, I was doing 4 in my head. Now we need 2 hydrogen. 2 times 2 is 4 reactants. 2 times 2 is 4 products. 2 oxygens, 4 hydrogens each side. Everybody's happy. Well, your chemistry teacher is happy, as is your examiner, which is very important, right? Next one, we have lithium. Lithium plus chlorine. Chlorine's up here as one of my diatomic gases. We're going to make something with lithium and chlorine in it, lithium chloride. Her hair, lithium's +1, chlorine's -1, that equals 0. So that formula is happy, but the equation is not balanced. So we've got 2 chlorines here, but only 1 here. So we need 2 of those and 2 of those. Straightforward, right? Yes. So that's that one. And the next one we're going to do is we are going to do potassium and sulfur. There we go. Let's have blue again. So K plus S. Heliboknofi namgal sipskla potassium. Potassium's there. So that's K, that's +1. Sulfur's under the oxygen, so that's -2. So it's K2S. 2K plus S will make 1 molecule of K2S, potassium sulfide. Beautiful. And then our last one is iron plus bromine. So let's have Fe plus Br2 will make FeBr2. We save the best for last. Okay. So we can balance symbol equations. We can give products for word equations. We can use the periodic table to work out what the charges are. So we can balance the formula to have a charge overall of 0. Determine the formula from the charges. Well, we've been doing that already. So let's do a little bit more. Calcium's group 2, 2 plus. Sulfur's 2 minus because it's over here. Sulfur, oxygen, Heliboknofi, namgal sipskla. So there is sulfur, -2 here. So that's happy, that equals 0. So the formula is simply CAS. CAS. Hydrogen and fluorine. We've got hydrogen, which is group 1, and fluorine, which is group 7. So that's -1 plus 1. Therefore, it's just HF. HF. There we go. You can see it now. Is the formula. Then magnesium with iodine. Well, Mg is +2. Iodine, fluorine, chlorine, bromine. Iodine is down here is -1. So we must have 2 iodines, because then 2 times -1 is -2, plus 2 from the magnesium. That gives us 0. So the formula is Mgi2. Formula from charge. It's only ever going to be group 1 plus 1, group 2 plus 2, group 7 -1, group 6 -2. Easy as that. Get them equal to 0. Happy days. State symbols and ionic equations. Just take care on the ionic equations. It can get a bit scary a bit quickly, but it doesn't need to be at all for GCSE. So if you can follow these, you're all good. State symbols, we have S, L, G, and AQ. S clearly stands for solid, L for liquid, G for gas, and AQ is for aqueous, which just means it's dissolved into water. Okay. Ionic equations, well, the first one is going to be HCl plus NaOH. You should all know this, NaCl plus H2O. You should also be able to look at these equations and pull out the ions and say, well, that's H plus Cl minus. HCl is H plus and Cl minus. And sodium is Na and OH is 1 minus. So it's Na plus, Cl minus, plus H2O, which doesn't ionize because it is a covalent molecule. When we're doing ionic equations, we cross out anything that's on the left and the right that is present. So here we have chloride and here we have chloride. So it's just what we call a spectator ion, just hanging around in solution, watching the rest of the reaction going on. Na plus here, Na plus there, that's gone. Now we're left with H plus, OH minus, and H2O. They're different on each side, so H plus plus OH minus goes to H2O. That is the net ionic equation. It would be very rare for them to ask that question, but it is on the syllabus, so you need to be aware that that's how you actually do them. The next one is a straight up displacement reaction, where it's just the most reactive metal displacing a less reactive metal. Zinc plus copper sulfate is going to make zinc sulfate plus copper. Zinc is solid, copper sulfate is aqueous. This is aqueous and copper is solid. So what's happened? Well, zinc has gone to zinc 2 plus SO4 2 minus, and copper here has gone from copper 2 plus, don't forget the SO4 2 minus, and it's gone to being copper. So what can we cancel out? Sulfate left, sulfate right. Everything else changes. So the overall reaction is going to be copper 2 plus zinc goes to zinc 2 plus copper. So we've got the state symbols, solid, aqueous, solid, and we've got the net ionic equation. We can then look at the combustion reaction. We use a simple one, nothing wrong with that, which is magnesium plus oxygen. Magnesium plus oxygen will make magnesium oxide. You knew that, right? Mg plus O2 goes to MgO. Mg is a solid, O2 is a gas, MgO is a solid. So we've gone from Mg to Mg2 plus, O2 to O2 minus. So that's the net ionic equation. Everything is used up. 100% atom economy, but we don't need to worry about that. This is a throwaway statement on your syllabus. Define atomic mass and molecular mass. So if you can, in your test, your exam, define the atomic mass as the average mass of naturally occurring atoms, it should say isotopes, but we'll let them off, of an element on a scale where carbon-12 has a mass of 12 units. If it says define atomic mass, it's the scale where carbon-12 has a mass of 12 units. Just state it, write it down, you get the mark. Okay. So 1g of H is going to be 1/12 the mass of the carbon atom, which is just an arbitrary line in the sand which chemists have chosen. Sodium has an atomic mass of 23, so it's going to be roughly double the mass for the same number of atoms. And oxygen is going to be about half as much for the same number of atoms. They've never asked you to do this. I was put there for your general interest. If you can recite the guidance which is there, then you are good to go in terms of your examination. Dastardly Moles equation. Why is it dastardly? Because N sounds like M, which sounds exactly the same as M. Thanks, chemists. So we know that N is moles, M is mass, and M, well, you can sometimes call it Mr. It could be atomic mass or the molecular mass, which would be the sum of the atomic masses. And now students, don't switch off just yet. Not yet. Okay. So moles is mass over Mr. They often ask you to work out the moles, given mass, and you have to look at the atomic mass from the periodic table. They ask you to work out the number of moles, given mass and molecular mass, and you can ask for the mass times in moles by molecular mass. So that you need to be able to remember, recall, and apply this equation to be successful. I'm sorry the letters are all the same, but this is one of only 3 things you need to remember to be successful at moles. Let's have a look. The next thing is number of particles. Now, Avogadro's constant says it's 6.02 by 10 to the 23. You just have to remember that number. It's a huge number, massive number. I'm not doing a presentation on that now. It's just a very big number. So how many particles in 1 gram of hydrogen gas? Well, the way to do this is first of all work out the moles and times it by 6.02 times 10 to the 23. So 1 gram of hydrogen gas. Each hydrogen atom has an atomic mass of 1g. There are 2. So 2g is the molecular mass of 1 molecule of hydrogen. We've got 1g, so it's 1 over 2, which is 0.5 moles. If 1 mole has 6.02 times 10 to the 23, half a mole must have 3.01 by 10 to the 23. 6 grams of carbon. Carbon has an atomic mass of 12. 6 over 12, so that's going to be 0.5. So it's exactly the same. The reason I've included this is because the same number of particles will have a different mass. Why will the same number of particles have a different mass? Because the subatomic particles that give the property of mass in an atom are the protons and the neutrons. And there are different numbers of protons and neutrons in these different elements. Okay, cute. So 10 grams of sodium hydroxide. Sodium is 23, oxygen is 16, hydrogen is 1. So the molecular mass, just add them together. 23 plus 16 is 39, plus 1 is 40. So moles is mass over Mr. 10 over 40, 1/4, which is 0.25. So that's going to be a quarter of 6.02, which is about 1.5 by 10 to the 23. And then 20 grams of magnesium oxide. Magnesium is still 24, oxygen is still 16, so it's 40. So mass over Mr. 20 over 40 is 0.5, so that's another 3.01 by 10 to the 23. So you can work out the number of particles. For IGCSE, it's always a nice thing to do. It's a half or a quarter or double. That's all they do. It's very simple arithmetic. They're not here to check your arithmetic, just that you know how many number of particles there are in 1 mole, which is 6.02 by 10 to the 23. Another little factoid is the 1 mole of any gas, doesn't matter what gas it is, has a volume of 24 decimeters cubed. So we're asking about methane here. We've got methane, which is CH4. They will give you the formula for that in the question. CO2 plus H2O. First of all, does it balance? 1 carbon, 4 hydrogens, 2 hydrogens. No, we need to have double that. Now I've got 4 hydrogens. Now I've got 2 oxygen. 2 oxygen is 4, 2 there, so it's 2 oxygen. Happy days. How much CO2 is produced? Well, I always ask students to put the data they're given in the question underneath the molecule to which it refers to. Got 10 grams of methane, so moles is mass over Mr, which is 10 divided by, well, carbon is 12, hydrogen is 1, It's times 4 of them, so that's 16. So it's 10 over 16. If I do 10 over 16 on my calculator, it's 0.625 moles of methane. The relationship between methane and CO2, and this is where the A's and the A stars get separated, is 1 to 1. So if I've got 0.625 moles of methane, I must also make 0.625 moles of carbon dioxide. Those are my moles. How do I get from moles to mass? Times it by the molecular mass of carbon dioxide. Carbon is 12, oxygen is 16, but there are 2 of them. 2 16s are 32, and 12 is 44. So 0.625 times 44, which I make 27.5. And that's in decimeters. No, that's in... Oh, I've done it in grams, and they wanted it in... they didn't ask, they said, how much? So that would be okay. We'll make 27.5, grams. That's perfectly okay. But let's do it using the molar volume of a gas, clearly times 24. So let's have 0.625 times 24 equals 15 cubic decimeters. So 10 G of methane would make 15 litres of carbon dioxide. That's huge, isn't it? A massive amount. That's why global warming is such a problem. Concentration. So we've got N, little n is little m over big M. We've got 24 decimeters cubed. We've got 6.02 by 10 to the 23 number of particles. And now we've got C equals N over V. So concentration is moles divided by volume. Don't forget volume is in cubic decimeters. So this is a 2-step calculation to work out what is the concentration. So first of all, we want moles, and then we need to factorize for the volume. Moles is mass over Mr. So this is 23, this is 16, this is 1, which equals 40. So it's 4 over 40 is my number of moles, and that equals 0.1. And it's in 1 decimeter cubed, so that's easy. 0.1 moles per decimeter cubed. Next one, I want to find out the moles. So sodium is 23, chlorine is 35.5, so that's 58.5. So 6 divided by 58.5 will equal, let's call that 0.1. That was a fluke. But now it's in 1 dm cubed. It's still 0.1 moles per decimeter cubed. Now I have KBr. Now potassium is 39, if memory serves me correctly. Let's have a look. ptable.com. So PCS is 39, and we'll also have the atomic mass for bromine to add them together for potassium bromide. So potassium is 39 and bromine is 80. 39 and 80 is 119. So that's 20 over 119, which equals 20 over 119 equals 0.17. But that's in 500 cm cubed, and we don't measure concentration in moles per 500 cm cubed. It's moles per cubic decimeter, which is twice the volume. Okay, so I've got 20 in 5. It's going to be half of that in 1 litre, isn't it? So it's going to be 0.085 moles per decimeter cubed. Does that make sense? 20 G over 119. 119 is K plus Br, that's the molecular mass. 0.17 moles in 500. And that will give us 0.17 moles per decimeter cubed. It's the concentration in moles per decimeter cubed. So if you're making it up, you're going to half that, of course, 0.085. Okay, we're on the home straight now. Let's have a look at some concentration calculations. So how much mass to make 500 cm cubed of a 1 mole per decimeter cubed solution of sodium hydroxide? So again, 2 steps here. We need to know the moles and factorize for the volume. So sodium 23, oxygen 16, hydrogen 1. So 40G is enough for 1 mole. But I want to make that concentration in half the volume. So the moles, let's put that mass. The mass that we would need would be 40 for 1 dm cubed. But for half that volume, we're going to just need 20G, because it's only 500 cm cubed, which is half of 1000 cm cubed. 0.5 moles of sodium hydroxide. Well, 1 mole is still 40 grams per mole. Half a mole is 20, because it's half of that in 1 litre. So it's the same, 20 grams, right? It's just that this one is half the concentration of this one. You could say this one is double the concentration of the second one. And then finally, it's still 40 grams per mole, because it's sodium hydroxide. 0.1 of 40 is going to be 4G. But we only need it in 100 cm cubed, which is 1/10 of 1,000. So it's 0.4G to make that solution. Now, limiting reactant and excess reagents. These come up regularly. They are straightforward arithmetically. The steps that I am proposing you use is the first one. Students always forget it. Balance the chemical equation. Then you work out the moles of the reactants that you can, and then with the second one, work out the moles of the reactants as well. Divide by any coefficients in a balanced chemical equation, look at the ratio, and you can work out the amounts of the products. The bread and the cheese is there. Here we have 1, 2, 3, 4, 5 slices of cheese, 4 slices of bread. Now to me, 2 slices of bread, 1 slice of cheese is 1 cheese sandwich. So I can use all the bread, but I can only use 2 slices of cheese. There are still 3 slices of cheese left over. The cheese left over is in excess, there's too much of it, and the bread is determining how many sandwiches I can make. That is the limiting reactant, and that's the concept that we're using in this chemistry question. So the first step was, that's right, it was 2 creates the balanced chemical equation. Mg plus HCl is going to make MgCl2 plus hydrogen gas. Easy balance, 2HCl. Write down the details, the numbers underneath the things that you're given. 6G of magnesium, 20 cm cubed of a 1 mole per decimeter cubed solution of HCl. How much hydrogen and how much magnesium chloride are produced is the question. So where do we begin? We begin where we can. This is a mass, so I'm going to be using N is little m over big M. This is a volume, this is a concentration, so N equals C times V. So N is M over M, so 6 over 24, which is 1/4, which is 0.25 moles of magnesium. Again, I'm careful to put my workings underneath the reactants to which it refers. Now, this concentration is 1 times 20, but it's 20 divided by 1,000, isn't it? Because we need to change from cm cubed into decimeters cubed, which is 0.02. This is moles. And that's moles. Now, these numbers are really far apart. Okay, so it's clear that the magnesium is in excess and the hydrochloric acid is limiting. But if they're close, it's easy to get mistaken. So what I say is divide by the coefficients in the balanced chemical equation. That would be 0.01. This is just 1, but we don't put it there, so that's still 0.25. The smallest number, this is limiting reactant. The biggest number is excess. Now, we don't use these numbers in any calculations. It's just a tool to work out which one is limiting, which one is excess. Okay, so the limiting reactant is 0.02 here. And this is where the A starts at A comes from. The reason we balance the equation is to work out the ratio. It's 0.02 moles of hydrochloric acid, but it's a 2-to-1 ratio. 2 here, 1 here. 10 of them will make 5 of them, 100 of them will make 50 of them. I've got 0.02, so I make 0.01 of magnesium chloride. Hydrogen is 2-to-1 again, so it's 0.01 moles of hydrogen. Hydrogen is a gas G, so I'm going to times that by 24 to get the answer in decimeters cubed. And this one, well, I've got moles, and I know Mr. the molecular mass because I've got the periodic table. So it's going to be 0.01 times 24 for magnesium plus 71 for 2 of the chlorines, which is 95. So that's 0.95 G. 0.01 times 24 is 0.24 decimeters cubed. We answered the question. The only hard bit was the ratio. Go slowly, you have enough time. Common errors. Students seem to use the wrong equation quite a lot for the question that's being asked. If it talks about mass, all you're using, N is M over Mr. N is M over M. However you've been taught, use it. If it asks for volume, C is N over V. That's the only equation with volume in your syllabus. Volume of a gas is 24. I know that that's at RTP. It's always 24. It's often not, but that's not on the IGCSE. And if it asks for limiting reactants, don't forget to do the ratio. The ratio will give you nirvana that you seek. Okay. I hope you found that useful. Don't forget, smash that subscribe button at the bottom. Thank you very much indeed for listening. Have a great day. Thank you.